All right, I got it now. Never mind.
You're going to want to avoid walking in front of the screen.
Yep. I will do that. Okay. Just want to make sure that people can hear me. Beautiful moonrise behind you if you haven't seen it. It's because it's so low on the horizon. Just like you get orange and red sunsets when the sun is very low. Interesting enough, if you're on the planet Mars, the sunsets are blue, and it's because of all the dust in the atmosphere scattering the red light. Yeah, you can still cover it with your pinky. Oh. They did bring some, I think, but I don't think we need them tonight. Well, thank you for coming out. We have a little bit of competition tonight, so hopefully you can hear me. We've been trying to find ways to continue doing these programs. We were doing these programs before COVID since 2005, every month. And then, of course, the situation changed and we weren't able to do the programs inside in the little tiny room in there. So as long as the weather holds, we will try to do something outside, and then once it becomes too uncomfortable, we'll find some alternatives. But we've, like I said, we've been doing these programs since 2005. Getting feedback? Okay. And we try to find topics that are both of interest and timely. So this month, if you've been following NASA's new moon rocket, they attempted to launch earlier in the month. Still working on that. But tonight we're going to talk about the program in general and the return to the moon. And return being the optimal word there. So we've been to the moon before. We weren't there for very long, and it was over 50 years ago. But Monday will be the 60th anniversary of the moon speech that President Kennedy gave at Rice University. And when you really think about how far out in a limb he went that day, he was committing to put a man on the moon and return him safely back to Earth before the end of the decade. And that was only an 8-year time period, and we had a total of 30 minutes of spaceflight experience at that point, and we had yet to put somebody in orbit. We had conducted 2 15-minute suborbital flights, and that was the total of U.S. manned flight experience. So Kennedy put that challenge out there, and you got to remember, this was back in the era when computers were as large as a room, and of course phones still had cords, and a lot of design and engineering work was done by hand using instruments like the slide rule. In fact, when Buzz Aldrin went to the moon, he brought along his slide rule to double check the computer, because we were still not real comfortable with computer calculations back then. But 7 years after Kennedy gave that speech, Armstrong and Aldrin walked on the moon. And it was a pretty momentous occasion. It really was a national effort. Over 400,000 people were involved in that program. Companies all across the country, thousands of companies, big and small, many right here in Connecticut. The Apollo program lasted just 3.5 years. We visited 6 different sites on the moon, all relatively close to the equator, all relatively safe as far as the landing terrain. The missions got more ambitious as we went on, but we never really extended the program to some of the more interesting sites closer to the poles, or maybe in some of the deep crater fields that the geologists really wanted to visit. So 12 men walked on the moon. The last one was Gene Cernan in December of '72. So 50 years ago this December was the last boot print left on the moon. And humans have not been back there since. We had a lot of grand plans to go back and to go beyond the moon. In fact, just 2 weeks after Neil Armstrong walked on the moon, Dr. von Braun was making a pitch to NASA to go to Mars. He had already come up with some rudimentary plans using the Saturn V rocket and the equipment that we had to go to Mars. We also had programs called Apollo applications, where we would go and spend a lot longer on the moon, do a lot more research, really get into some of the science available. And again, that wasn't funded either. So there were a number of reasons the program was canceled, a lot of economic reasons, a lot of competing interests. If you remember back then, we were still heavily involved in the Vietnam War, which was tying up a lot of resources. But we learned quite a bit. We brought back samples from, again, those 6 sites, and we learned a lot about the moon that we couldn't have learned otherwise by not going there. We learned that the moon wasn't formed along with the Earth. It came a bit later, some less than 100 million years after the Earth was formed, the moon was formed. We learned that it was a fairly violent event, and that the moon, almost the entire surface of the moon was molten at one time, an ocean of molten rock. And from that ocean of molten rock, as it cooled, a lot of the lighter elements floated to the surface and created the crust that we see today. So that the lighter parts of the moon that you see tonight, that's part of the original crust. That dates back 4.5 billion years. So when we go to the moon, we find that the entire surface is really covered with a layer of crushed rock. And within that layer is embedded things like hydrogen. Now that's from the solar wind. The solar wind is a stream of particles that comes from the sun through openings in the magnetic field. And a lot of that gets embedded in the lunar soil, which can be harvested. So there's a lot of resources at the moon that are of interest to people. So it's not like we've given up on the moon. There were dozens of robotic missions that happened after Apollo. And some of them, like the latest Chinese mission, did bring back samples from the moon back to Earth. But a lot of the orbiters and landers have added to our knowledge base. And the one that has been in orbit since 2009 and has really contributed to our planning for our next steps is the Lunar Reconnaissance Orbiter. And the orbiter has been able to map the entire moon surface, the topography, the abundance of minerals. It's been able to, with some of its instruments, detect the possibility of water ice on the poles of the moon. So with this particular spacecraft, we've been able to do a lot more detailed planning for Artemis than what we did for Apollo. We didn't have that advantage. In fact, the cameras on the Lunar Reconnaissance Orbiter are so good, they can actually see the Apollo equipment that was left behind. And if you look at this image, you can see that right in the middle here is the descent stage for Apollo 17. That's the piece of the lunar lander that was left behind. In fact, the cameras on the Lunar Reconnaissance Orbiter are so good you can actually see the tracks that the rover left behind in the lunar dust. So, big benefit. So where do we go? We left Apollo 50 years ago. We're going back, and we're going back with a program called Artemis. Artemis is named for the twin sister of Apollo. So we're carrying on that connection. So why are we going back? Well, the moon turns out to be really a key to a lot of what's gone on in the solar system over the past 4.5 billion years. And because the moon doesn't have the weathering and the other processes that the Earth has, doesn't have tectonic plates, doesn't have oceans, doesn't have a means of erasing that history, the moon retains a lot of that history of the early solar system that we can't find on Earth. So if we want to know what happened on Earth billions of years ago, the moon is the place to find it. The moon also contains the history of that late period of planetary formation in our solar system. It also has what we found an abundance of resource that might be very interesting that we could use. Certainly a lot more interesting than trying to carry resources up to the moon if we can find resources that we can use already there. And long term, we're looking at as a stepping stone. If we learn to live and work on the moon, we can use that experience to move on to other places like Mars. The other thing we found with Apollo that we couldn't do with robotic type spacecraft, there's something about having boots on the ground, having that human element, looking at a rock and realizing that rock is potentially significant, or scuffing up the soil and saying that orange soil looks like volcanic glass from a fire fountain. Something that you're really difficult to do when you're putting machines in place of a human. So there's a real benefit of having that human element. The other interesting thing is that 50 years ago, when we brought back those samples from the moon, we had the foresight to realize that we didn't really have the technology back then that we might have in the future to really understand these samples. So we sealed away a good portion of the Apollo samples and left them unopened. In fact, just this year, this spring, we're now opening some of those samples from Apollo 17. And with the new instrumentation and the modern technology, we are able to really do an analysis on the lunar samples that wasn't possible 50 years ago. So with the advances in technology, there's a lot more we can learn from going back to the moon. The colored map of the moon on the right side there, the colors, and you see the acronym of CREEP. CREEP stands for potassium, rare earth, and phosphorus. So there's an abundance of rare earth elements on the moon. And rare earths are used in just about everything these days as far as high-tech applications. And also the primary source of rare earth elements these days is China. So the moon might be another alternative. So how are we getting there? Well, NASA has assembled a moon rocket. It's kind of a hybrid rocket. We'll get into a little bit about the various components. And they call it the Space Launch System. Instead of the Apollo capsule, now we have the Orion. Orion is just a high-tech spacecraft that will carry 4 astronauts out to the moon. NASA is also planning to put what they call Gateway. Gateway, think of that as a small space station in orbit around the moon. So it's going to be a way station. The Orion capsule will go out to Gateway, dock with Gateway, and transfer astronauts into a lunar lander, which we call the Human Landing System. All these new acronyms. So what you see in the launch pad right now down at Kennedy is version 1 of the moon rocket. And they're expecting to develop additional capabilities, different versions of the rocket depending upon what they need it for, whether it's carrying cargo or in the future whether it's going to Mars. So the current version is a little shorter than the Saturn V was that we sent Apollo astronauts to the moon. It's got more thrust, which means it can carry more payload. As I mentioned, it's a hybrid. It takes elements of the space shuttle and uses those, incorporates them into the moon rocket. So not only do you have a core stage, which is the orange cylinder, but you have solid rockets on each side, which are taken from the space shuttle. And the core stage is powered by 4 space shuttle engines. And you can see those engines right there. So we're recycling and reusing engines from the space shuttle program for the core stage of the SLS. The solid rockets are essentially much like the space shuttle, only they've added an additional segment. Space shuttle solid rockets were 4 segments. We've added a 5th segment for the Artemis program, and it gives us 25% more fuel, higher thrust. The core stage is comprised of a very large liquid hydrogen tank and a smaller, which isn't shown in this picture, liquid oxygen tank. So the hydrogen tank is over 500,000 gallons of liquid hydrogen. The Orion capsule is a high-tech version of the Apollo capsule. But it's also designed for deep space. Apollo was designed for the moon. Orion is designed also to go into deep space. It carries a crew of 4, and it's powered by a service module that was provided by the European Space Agency. So here you've got a collaboration of different agencies contributing. As I mentioned, the Gateway is a small space station in orbit around the moon. And astronauts will be able to live and work on the station short periods of time. And then it'll be a transfer portal down to the lunar surface. Little better view of the space station there. So last year, NASA awarded a contract to SpaceX for the lunar lander. It's basically a version of SpaceX's Starship. And the Starship will take astronauts from the Gateway space station down to the surface. So the first mission, Artemis, is a series of missions, each building upon the previous mission. The first mission, Artemis 1, will not have any crew on it. It will go out past the moon, about 40,000 miles past the moon, deep space. It's basically a test program It will last anywhere from 30 to 40 days, and it's really an opportunity to test out all the various systems. There will be a crew of 3 mannequins that will provide data. 2 of the mannequins are provided by the German aerospace company, and they will be covered with dosimeters. So they'll give us an idea of what the radiation levels are in deep space for astronauts. The 3rd mannequin is a U.S. mannequin, I guess you'd call it, and he's looking at the acceleration, other forces that the spacecraft will have on the human body. If all goes well, Artemis 2 will actually have a crew, and this mission will be to go in orbit around the moon. It'll last a week or so, and it'll test out the spacecraft again with human occupants. Tentative launch is 2024. Artemis 3 is really the mission everybody's looking for down the road. It'll be the first attempt to put people back on the surface of the moon. By that time, if everything goes well, we will have Gateway in orbit. So the Orion spacecraft will dock with Gateway. 2 astronauts will transfer into the lunar lander and go down to, right now we're looking at the south pole of the moon. A very interesting location. So why would we go to the South Pole? We didn't venture anywhere too far from the equator with the Apollo program. Relatively safe destinations. Well, the South Pole is pretty intriguing. There are parts of the South Pole that are in sunlight 90% of the time. So if you wanted to set up a solar power station, certainly it would be nice to have sunlight almost continuously. You remember, a lunar day is about 14 days long of sunlight and 14 days long of darkness at the equator. So the South Pole gives you a real advantage there as far as sunlight. There's also areas at the South Pole that never see the sun. The sun's only about 1.5 degrees above the horizon at the South Pole. So it's very oblique. There are areas inside craters that have never seen sunlight, and they're some of the coldest places in the solar system. And that's where we think there's the good possibility that there's water ice inside those craters. So just to show you some of the play of light and shadow at the South Pole, this movie is developed from images from the Lunar Reconnaissance Orbiter, and it shows you a 2-month time span, and we're looking right down at Shackleton Crater, which is right at the South Pole. So this is a ridge, one of the potential areas that we're looking at to land. But you can see over the course of 2 lunar days or 2 Earth months, it's a constant play of light and shadow. Again, it's not an area that'd be familiar to us because, again, we spent most of our time in the 60s and early 70s near the equator where you had the sun high in the sky. This is a very low sun, and you get these very deep shadows. So one of the instruments on the Lunar Reconnaissance Orbiter can detect hydrogen. And of course, hydrogen is a component of water. And what they've done is they've mapped the area around the South Pole. And these are areas where they believe there's an abundance of hydrogen, or the equivalent of water ice. NASA has selected 13 different locations at the South Pole that might be suitable to land on, depending upon how rough the terrain is, the lighting conditions, how easy it is to communicate with Earth from these locations. So they haven't selected one yet, but these are the 13 areas, and they're all around the South Pole, as you can see. The big advantage is that you can set up a base that is almost always in sunlight and yet be right next to a crater that is always in shadow, where you might find these lunar ices. Oh, just some of the pictures that have been returned of Shackleton Crater, which again is right next to the South Pole. It's a very different landscape, almost kind of an eerie landscape. So why are we so interested in water ice? Well, water ice is hydrogen and oxygen. We can break that down. Or we can use it for drinking water, or for watering our crops. Water is also an excellent radiation shield. But if we break the hydrogen and oxygen down, of course, we have breathing air, or we can make rocket fuel. So really, if we can find deposits of water ice on the moon, it would greatly simplify our long-term stay on the moon. We wouldn't have to bring all those resources with us. That said, we are not without competition. Of those 13 areas that NASA is looking at least 3 of them are on the same list that the Chinese have. And they are also planning to go to the South Pole at the same time. So it could get kind of crowded down there. So if you've been following the attempt to launch Artemis 1, you realize they've had 2 delays where they got close to launching it, but they did not for various reasons. Again, this is a new system for them, and NASA wants to make sure that they do it right, and they're being very cautious. Of course, the weather in Florida doesn't help. You can get some real nasty weather down there, including some lightning strikes. So the latest issues that they've had are leaks. When they've been fueling the rocket, again, the core stage uses liquid hydrogen. And if you go back to your high school chemistry class, hydrogen is the lightest element. It's only a single proton. Doesn't take much of a breach to allow hydrogen to get through a seal. And that's what's happened, is that twice we've been trying to fill the main tank on the rocket, and we've had a leaky connection. And you really don't want to leak too much hydrogen, because anything over 4% is explosive. So you have to be extremely cautious, and they've done that. They've stepped back every time they've had a problem. So currently they are out at the pad, and they are changing out the seals in those connections that connect to the rocket. If you see that gray housing I've circled, inside that housing is the line that runs from the tank farm that feeds the rocket, and the hydrogen goes into that connection at the bottom, at the base of the rocket. So that gray structure is called the tail service mask umbilicals. And the reason it's there is because those lines that feed the rocket fuel are there right to the last minute before launch. So as the rocket is ready to launch, those lines have to disconnect and they have to disconnect very quickly. And what these gray structures do is they retract the lines quickly, and they bring them back into those housings, and they close a shutter to protect the lines. Basically blast doors. So you can see sorry. You can see one of the connections there. And on the right, this is a test inside the vehicle assembly building. And you can see how they're practicing the connection and how the lines fold up into the gray housing. See the line on the left, it'll disconnect and then rotate back up, and a door will close. So they have to make sure that these things can disconnect quickly, but when they are sealed to the rocket, they are sealed tight so the hydrogen doesn't leak. So for the past week, they've been out on the pad changing out the seals inside those lines. And so they've gotten that issue down. The other big issue that's preventing them from launching right now is called the flight termination system. Whoa. The Space Force is responsible for safety when it comes to any launch on the East Coast. And the rockets are equipped with a self-destruct mechanism. So if they happen to veer off and they're going to endanger the public, there's an ability to destroy the rocket. Well, that self-destruct system is battery powered, and it's only certified for a certain length of time. And this is not NASA's call, this is the Space Force's call. So NASA needs permission to go above and beyond what the Space Force believes is a reasonable time. So originally the batteries were only certified for 20 days. NASA had a waiver for 25 days. And of course the batteries have to be tested prior to going out in the launch pad. So once you get out in the launch pad, you don't have that long a duration in which to launch. And with the hydrogen leaks, of course, now we have a big delay. So NASA has to go back to the Space Force and ask for additional waivers if we're going to launch. Otherwise, we have to bring the rocket all the way back into the vehicle assembly building to change out the batteries. So, assuming NASA gets a waiver, the next launch window is at the end of September, September 23rd. And if that doesn't go, they're hoping maybe the 27th. There's another mission between those two dates that NASA is not going to launch between those dates, called DART. And that's because DART needs the Deep Space Communication System during that period of time. So what happens once we get there? Well, the long-term plan is to colonize, stay on the moon, establish a permanent presence. It's going to be a long time before we have moon cities. But some of the latest thinking is maybe we need to look at going underground. There are volcanic structures on the moon that run beneath the surface. And occasionally those lava tubes, the roof of the lava tube will collapse and form these pits. And latest studies of these pits have been that these pits stay at a relatively constant temperature, just like you would find a cave on Earth. And they might be very suitable for astronauts to build a shelter out of. One, they provide radiation protection. Again, they provide a fairly constant thermal temperature. And there's a number of reasons why we might want to look at going back and using these already there lunar caves for shelters, at least in the short term. The other complication is that we're not the only people interested in going back to the moon. There are many countries interested. There are private industries that are also looking at going back to the moon that didn't have these capabilities back in the 60s. So it raises a whole bunch of questions on how do you develop resources, exploit resources on the moon, and how do you do that with other competing countries doing the same thing. So right now we don't have a former governance structure or legal framework. Something that needs to be worked out if we're going to have multiple entities on the moon competing for the same things. Long term, NASA is talking about going to Mars, but Mars is not necessarily a next step. It's not even a big leap. It's really an exponential leap. When you talk about going to the moon, you can get there in 3 days. You can get back in 3 days if something goes wrong. If you want to go to Mars, we're talking a minimum right now of 6 months out. And then depending upon where the planets align, you may have to wait more than a year to turn around and come back. So it's a lot more complicated, a lot more challenging than going to the moon. Mars presents its own sets of challenges. Again, the distance being one of them. Not just communications and travel, but supplies, all the things that could happen when you're on the surface of the planet that you might need support for. It's just not forthcoming. It's not something that can be responded to quickly. Mars is very inhospitable. It has global dust storms. It doesn't have a magnetic field, so the surface is bathed in radiation. It's got temperatures at night that go down well below 150 degrees below zero. So it has its own set of challenges that the moon doesn't. So getting to Mars is very hard and dangerous, and fortunately we have the moon to practice on, because it's going to take a lot of living and working on the moon before we're comfortable moving on to something as far away as Mars. So I appreciate you coming, and thank you for your time. And we probably still have some telescopes looking at the moon at least. I did see Jupiter come up a little while ago, so please take the opportunity. Saturn is still up, still visible, and hopefully the clouds will part enough so you'll be able to see Jupiter before you leave. But please take the opportunity. Thank you. You're very welcome. Oops. Sorry about that.
Next time I'll bring a special buddy. Thank you very much.
You're very